Do, 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 do. So if I said, I had a total of 48 people. Some were, what you got, Jeff? Some voted for Bob. Some voted for Fred. Right? So how many voted for Bob? It's the thing you get over in algebra. There's things we don't know, but we kind of pretend like we know them for a minute. How many people voted for Bob? Do you know? X. There you go. I don't know. Yes, we do. It's X. So then how many must have voted for Fred? 48, the total, minus how many voted for Bob. That makes sense. That's the general idea of what you would do. If you know two things add to 48, and one of them is something, how do you figure out what the other one is? 48 minus that. Same thing you do with the fish. Same thing you do with whatever the other problem is.
So the cost really didn't matter.
Not at first. The unknown is the number, right?
Okay.
Then if I said everybody here gave me $5 and everybody here gave me $10, that goes into the equation. Yeah. So you don't bring too many things in at once. Your unknown was the number of people that did this, or the number of fish, right? The number of each kind of fish. There's no cost involved there.
Oh, and
then you build the cost into the equation.
After you figure out how many of each was.
Yeah, so again, if I said these people gave me $5 and these people gave me $10, I like it, Jeff. And I made a total of $400 total. That's the equation now. The equation is going to involve money.
Okay.
So each of these guys gave me $5. That's 5x. Plus 10 times 48 minus x. And then I can figure out what x is.
Oh, okay. You just pieced it together slow.
The equation deals with money. The unknowns were the number of. Right? And for some reason, either you think you're supposed to bring the money into play early, or you just don't know what the hell to do with the money thing. I understand that. But the question said, how many? Therefore, your variable is number of, no money involved in the statements of the variables. I like it. Okay. It's a nice little trip down memory lane there. I think from the last thing we did, we got into y equals mx plus b stuff. I like it. We did a few problems like that. So let me give you guys this here. Bless you. The first part of this kind of captures what we talked about yesterday. Oh, scheisse. People so, don't worry, that's all you. I'm going to get everybody in the back here in a minute. I'll put that phone away. Don't worry, stay there. Everybody just loves the back row so much. I
don't know, I just like the back better.
I didn't say anything wrong with it, did I? As a student, I knew I had to sit away from the window or else I wouldn't pay attention. I was always looking out the window.
No windows.
No windows in here, so everybody's good for that. Okay, so take a look at this. Let's take a look at this. Now that I put you to sleep, wake back up.
It's the longest. Do the longest.
All right. Go ahead and do the first couple of problems on there. Let's see if you guys remember how to do that. We did that before yesterday, but we definitely did it yesterday. Do the first couple problems on there. Yeah, these two here, the ones graphing the lines.
Sorry.
You're good.
Okay, so for a line, all you really need is a starting place and the direction to go in. So I start off specifically with saying if they give us a Y-intercept, which is one option for a starting place, and the slope, which is the direction to go in, I can graph the whole line. Now let's see if this makes sense. I've been trying to make this connection this whole time. There's a valid direct connection between a graph and the equation. So if I have enough information to create the graph of something, I have to have enough information to find the equation of that thing. Because those two things go together. Oh, you didn't get one? Yeah, you can have one, I guess. All right. So if I plot 0, -2, where's that going to be if I plot 0, -2? Where would that be?
Oh, down.
Down 2. Okay, I like it. And then the slope of 3. And what can I put 3 over what? 1. So I would go up 3. 1, 2, 3.
And
1 over. Wow. Now let me, I didn't ask for this, but since we already talked about this piece yesterday, can you guys write the equation for this? What's M? 3. And what's B?
2,
No.
1,
No.
minus 2.
There. B is the y piece of the y-intercept. So that's the equation, right? I constructed the line, then I wrote the equation. I could have done it either way, really. Now that I've got an equation written, how can I kind of double check the line I drew? What point did we go through? What's this? What point is that? 1, 1. So if this is the correct graph for this, what should happen when I put 1, 1 in here? What should happen? If that point is on the line, it should do what in the equation? It should make the equation. I would take a few different words here. It'll make the equation true. It'll make the equation work. Right? You guys with me? We've done this before. If it's on the line, it must work in the equation and vice versa. So what do you get when you put a 1, 1 in? 1, 1. You get a valid equation, don't you? Therefore, that looks to be the line that goes with that equation. It's a beautiful way to check your work. When you are finding another point using the slope and you have an equation, you can plug that new point in and make sure that you're on the right track. It should work. So do number 2. Try to plot the line and then try to figure out what the equation is. This thing is annoying. First off, I want to desperately correct this craziness. There we go. Now it's a y-intercept. So just like we just did, you plot the y-intercept. Now what's this slope tell me to do? Yeah, go down 3, 1, 2, 3. Now let's make sure this makes sense. It is negative 3 over 2, right? So this is really cool. You got to stay with me now. Isn't this, can I put the negative on the top? I could also put the negative on the bottom. And they are both the same, right? Math goes, whatever you want to do, man. They're both negative. That's all it cares about. But what does this tell me to do? It tells me to go down 3. And then in the positive direction 2. If they were both negative, the negatives would cancel. But isn't it a negative slope? It's a negative slope, right? You guys see that? Down 3, right 2. Okay. Or I could have gone up 3. Stay with me now. What's this one tell me to do? Go up 3, 1, 2, 3, back 2. Am I still on the same line? Of course I am. Maybe. So this is my house. This is my friend's house. And my friend says, go south 3 blocks and then east 2 blocks, right? How do I get back to my house? I can go up, I can go north 3 blocks and then west 2 blocks. I mean, I have to be able to go both directions. Is that all right? Just don't make them both negative. Because then the negatives would cancel. And it would be positive, but it's not positive. And also, what direction should a line go in if it's got a negative slope? It should go down as I read. Left to right. So that's a good little check at the end. Make sure it's actually going in the direction it's supposed to be. We're sad if this is a profit of our company. Right? That's why the slope is negative. It's a sad thing. Okay. I like it. What do you guys get for the equation of this line? Y equals, what's the slope? Negative 3 over 2x. And what's b? Plus 2, because the 2 is positive. Bam. And then again, if you want to check it, what point is this? 2, negative 1. Right? 2,
Yes.
negative 1. If you plug a 2 in, the 2's cancel. Negative 3 plus 2 is negative 1, exactly the way it's supposed to be. Okay, I like it.
Oh, kind of like if
Multiply
it
by
was
2?
M2 plus M1 equals negative. Something like that.
I don't know. I'm not sure what that is. Sorry, Curtis.
Figure out what you were, if the line was.
Yeah, you just plug that X and Y value. You plug this in and make sure you get that out. That would mean that the point works in that equation. Okay, all right. How you guys doing? Everybody all right? Okay. All right, so take a quick minute, do these. We did these last time too, but just to review. So real quick, what do you guys get for the slope on this first one?
The X is 0?
No. What do you get for the slope for this first line? 2. Okay. And what's the y-intercept?
3 minus. Minus.
0, -3? Is that what you're trying to say? Okay. I don't have to be such a jackass about it, but a y-intercept is a point. So when you tell me the y-intercept, you must tell me a point. Otherwise, you're not telling me a y-intercept. All right. So the problem with these two is easily fixed. What's the problem with both of these? What's the matter?
I don't understand why it doesn't only got 0.
Okay. Y-intercept is a point. You with me on that? Therefore, the answer to a y-intercept can't have a number, because that's not a point. A point has 2 parts to it. How do you find the y-intercept always? You make
X0.
x0. So the x piece of the y-intercept will always be 0. And in fact, I think you were just saying that earlier. If you make x0, you do get -3. That's kind of like yb is always the y part, because if you make x0, the mx piece goes away.
Just 0, not a number.
Because if you put a number in for x that wasn't 0, you're not on the y-axis anymore. You've moved over. I like it. So these two, what do you have to do with these two first?
Y by itself.
Do y by itself. I love it. Keep going.
Divide by 3.
Well, I mean, keep going. You keep going. Yourself. If you're done with it, just hang out for a bit. So let me show you a little nifty thing. You want to be really nice to yourself. So put 3 underneath each piece. Everything gets divided by 3. Nobody can escape. Of course, here you just get y. Wow, that's bright. Rawr. Y equals, now the best way to write this piece, anybody know what the best way to write this is?
Minus the X.
Minus 1.
Say all of it.
Minus
1/3 x. That's the best way to write that. That's the nicest way to write that for yourself. Because then m is just going to be what? What's the slope going to be? What's the slope? -1/3. The slope. If you solve for y, the slope is always the number in front of x. Always. And we talked yesterday about why that is. We did a few examples to make it make sense. So now that we know why it makes sense, we can just use that fact directly. And of course, what do you get here? You just get something gross, but oh well, too bad. So the slope is -1/3, and the y-intercept is 0.4. Right? Because that's what's here, isn't it? So that'll be B. I like it. What do you guys get for this on the next step after this? What do you do?
2 divided by 2.
No. You can, but why do that to yourself yet? You're trying to get the y piece by itself. So of course, what am I going to subtract? Subtract 2x. Trying to get the y piece by itself. So try to get the thing with y in it by itself first, right? Bless you. Now, how would you guys write this side?
For y equals -2x plus 5.
Yeah, so we can all be nice to ourselves. You don't have all the power all the time, but sometimes you have some power. So I can choose which way to write this, and I'm going to put it closer to mx plus b whenever I can. Now, it's not really technically wrong to write 5 minus 2x. You're just being a little mean to yourself, right? Okay. And then I divide each piece by 4. So y equals, what's this become? Negative 1/2 x plus 5/4. I like it. Thankfully, I'm not asked to graph these because that's y-intercept is a little bit disgusting, but too bad. So the slope is going to be negative 1/2, and what's the y-intercept? Huh? Huh?
0, 5.
There we go. I don't care if that gets annoying. I don't care. If it's annoying and it stays in your head, that's fantastic. Yes. Just like a jingle.
You simplify the negative 2x over 4 to 1 over.
Oh, totally. You got to reduce whenever you get something you can.
Okay.
But be really careful. Don't do 2 divided by 4 and get 2. That's some magic shit. Right? And then your graph is going to really be wrong. Okay, so be really careful. Reduce it for real. And what about 4? 4 is freaky. 4 is there's not much to do. But what is it there that we normally are trying to do something with? Y is not there. So what kind of line is this? Anybody remember? Is it? It's a special case.
What is that?
Vertical. It's a vertical line. The way to remember this is, can x change in that equation? The equation says x must be negative 2. And when x changes, which way do I go? Left and right. So if x cannot change, I'm catching up to you, right? If x can't change, I can't go left and right. I can only go up and down. So x equals will be a vertical line. Y equals will be a horizontal line.
Minus 2
Yes.
point 0.
Say again?
Minus 2.
Nope.
No.
So again, this might even be good to graph this thing real quick. Here it is, right? At negative 2, it goes straight up and down. Is that cool? What's the y-intercept? There it is. There is none.
Minus 2.
There is no y-intercept. Does it ever hit the y-axis? No. In fact, the y-axis and this line are parallel. Holy shit. I don't care how long you go, it's never going to come together, right? So no y-intercept. So the special cases always are weird in some cases. So this no y-intercept. And what's the slope?
0.
No, 0 slope should be flat. This is the exact opposite of flat. Infinite. I love it. Slope is infinite. Or undefined even. You can hear some people say undefined slope. But infinite slope. It just goes up, and that's all it does. That's infinite. Okay, all right. Huh? What's up? You all right?
No,
What's the matter?
I'm sick.
I'm sorry.
I'm here.
Okay. All right. I'm sorry you're sick. As long as it's not the math that's making you sick. As long as it's not the Budweiser virus.
You mean to me.
Come on, I'm a teacher. I gotta be mean to you no matter what.
Still writing this down.
What's up? I'm sorry.
Under, 4.
There you go.
Thank you.
So, oh, let me keep this. There you go. On the next page, I've got a couple more things. What I want you to do on the next page, you see where it says 2x? Are you good? You good?
Yeah.
Okay. Where'd you go, Freeze? There you are. On the next page, it's got this here. So for these two problems, write down what the slope is, write down what the y-intercept is, and then graph them just like we did in these first problems, right? That's all you need to know is the y-intercept and the slope. So this first problem, you don't have much work to do to get those. Second problem, you got a little bit of work to do. So figure out what the y-intercept and the slope are, and then graph the line just using the y-intercept and the slope. So we're putting together everything we did on the first side. You ready?
Yeah.
It's a weird day today. Everything all right over there?
Yeah, thank you.
Man,
That's so weird.
it's a weird day. All right. When you get over, we turn on. No. Yes, M is the slope. Slope is 2/1. The y-intercept, 0, -5. So if you plot the y-intercept, you can use the slope to move to find another point. Yeah.
Oh, I need to add that?
Yeah.
Yeah, okay.
So then it's just a positive.
Right. So that's 3? Positive.
Yeah.
All right, so let me catch up on this first one.
You divide by
What's the slope on this one? 2. So slope is 2. I could put that over 1. So it's more like rise or run. What's the y-intercept? 0, -5. Kick ass. I've whipped you guys into submission. So 0, -5. And then from there I go up 2 over 1. Okay. I can do it again. 1, 2 over 1. I can do it here. 1, 2, or I can go crazy. But is that cool? You don't have to do all those other dots, but you know, kind of makes it easier to make a straight line if you give yourself a few more dots. So now I could actually check any of these points if I wanted to. So this last point I went through is 3, 1. And sure enough, if I put a 3 in, I get 6 minus 5 is 1. So the output is correct. Okay, maybe. All right, so number 2 is the exact same thing. I just have to do a little work first, right?
Either way.
Yeah.
Back through, yeah.
Same line.
Yeah.
As long as the arrow's going out.
Because if you go plus 3 or
Minus 2 over 3.
say
Same line.
you just have
All right, so I'm going to kind of do some of this. Oh. So I get y equals -2/3 x minus 3. That's what I get. So the slope is -2 over 3, and the y-intercept is 0, -3. Kick ass. Let me zoom out a little bit. I'm way the hell in there. Focus. Focus. Okay. So then 0, -3. That gives me a starting point. And then from there I want to go, I can either go down 2, right 3, or I could go up 2, back 3. Because either way there's a negative that makes the slope negative. Same. And you can see you're on the same line still, right? And again, that's just the physical idea of if I go from my house to the store, please tell me there's a way to get back to my house. I mean, that's all it is. If I can go from that point to that point, I gotta be able to get back. Holy shit.
Not downtown.
Good point. Got a ton of one-way things. And then when I first moved to California, I call it the no U-turn state. If you're going the wrong way and there's cops, just screw you. Just keep going. You're gonna go wherever this goes. Anyway, sorry. A little rant. I didn't realize I was still bitter about that. I thought I'd gotten over it. All right, how are we feeling about it? I really want you guys to realize if you had not much trouble with this one, for example, these two, we just did the same damn thing. It's just we had to first figure out for ourselves what the slope and the y-intercept was, and then we did it, right? All right, this is the reverse of what we just did. I give you a line that's finished, and I ask you to find the equation of it. So watch. You all right? What's the matter? Is this one okay? Oh, all right. I guess I kind of opened myself up to that. Okay. So if the equation, here's what's called slope-intercept. I don't know if I've actually uttered this phrase yet. And math people being as creative as we are, we said, oh, it's the slope and the intercept. Let's call it slope-intercept. So that's where the name came from, if you want to use correct grammar. So what's B mean always? The y piece of the y-intercept. So what's B going to be? 2. So I know what B is. 2. Can you see what the slope is? Yeah, it looks like I go down 2 over 1. Let's check. Down 2 over 1. Let's check it down 2 over. Yeah. Do you guys see that? So, okay. Pick any point the line goes through, like right there, right? How do I get to the next point? I go down 2 over 1. Do you understand how that's exactly what we did up here? To create the line, I can then see what it is from a line that's already been created, right? Do you guys see that?
Yes.
So then what goes in front of the x? Whoa. Where are you? So again, down 2 over 1. So negative 2 over 1. That was just out of nowhere.
I went from the points, I looked at the points first to see where they were stopping. I mean.
So, all right, but any point you